This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. On this video, we're going to use the basic identities to rewrite the expression given and then simplify it. And we're going to begin by writing everything in terms of sine and cosine. So these are the basic identities, the reciprocal identities, tangent and cotangent in terms of sine and cosine, and the three Pythagorean identities you need to be familiar with in order to work some of these problems. So here's the first one. 1 over tangent squared x minus 1 over sine squared x. So let's begin by writing everything in terms of sine and cosine, or we can use a reciprocal identity to write tangent squared x. If that's in the denominator, remember you could write that as cotangent squared x in the numerator. So I'm going to do that since it's the reciprocal. Then I have cotangent squared x in the numerator over 1 minus 1 over sine squared x. So I haven't written this in terms of sine and cosine yet. And in fact, I'm just going to leave this as cotangent squared x. But this is one way to start. And then we could change this cotangent squared x to cosine over sine. So if you have the cotangent squared x, it's really the cosine of x over the sine of x squared. So basically each of them will be squared. All right, so this is one way to start this problem. Now I have a common denominator, which is convenient. So in the numerator, I have cosine squared x minus 1 over sine squared x. Now at this point, you may think you're done. But cosine squared x minus 1 can be simplified a little bit further. So you should be familiar with the Pythagorean identity, cosine squared x plus sine squared x equals 1. And so if we could manipulate this so that we could have on one side of the equation cosine squared x minus 1, we'll be able to do a substitution. And in fact, you can do that. If you subtract 1 from both sides, we have cosine squared x minus 1. If we subtract 1 from both sides, we'll have that on that side. And then we'll have a negative sine squared on the right. This means I could replace the numerator up here with negative sine squared x. All right, so that's one way of getting a different numerator. Another way of doing it is simply replacing cosine squared x with, well, if I wanted to solve for cosine squared x, I'd have cosine squared x equals 1 minus sine squared x. So that's another way to do it. Let's just do it that way. So I'm going to replace this with 1 minus sine squared x. Now you want to get really familiar with these. Cosine squared x can be written as 1 minus sine squared x. Sine squared x can be written as 1 minus cosine squared x. So I've replaced it, but I also have this minus 1 over sine squared x. But notice what happens. 1 minus 1 is going to go away, and you have negative sine squared x. So if you would have done it the first way I said, just simply replace that whole numerator with negative sine squared x, you'd still end up with negative sine squared x in the numerator and a sine squared x in the denominator. And now this means negative 1 times that, right? So we can cancel the sine squared x, but you're going to still have a 1. So your final answer is going to be negative 1. Always keep in mind there's more than one way to do all of these problems. Some people might notice that they know that cosine squared x is 1 minus sine squared, right? And that means the sine squared x is 1 minus cosine squared. And when they see this cosine squared x minus 1 right here, they say, oh, that's just the opposite. So instead of it being sine squared x, they figure out it's going to be sine squared x. There's all sorts of different ways people think about this. But in the end, we should end up with that this whole thing simplifies to negative 1. All right, here's our next one. I'm going to just begin by rewriting the cotangent in terms of cosine and sine. So this gives me cosine of x over sine x times this sine x. I still have minus 1. And this already is in terms of cosine, so I just leave it as is. But when I do this, I see I've got sine x and sine x will cancel. So I just have cosine x minus 1 times cosine of x minus 1. This is real similar to the one we just did. This is cosine squared x minus 1 because it's a difference of two squares when you do the FOIL method. Cosine squared x minus 1. Well, we just went over that in the last video, that cosine squared x could be written as 1 minus sine squared x, right? So this one, we just end up with negative sine squared x. It's easy to leave your answer as cosine squared x minus 1. It's just slightly more simplified maybe to think of that as negative sine squared x. The idea is that these are actually all equal to each other at each line. And it's not necessarily true that negative sine squared x is simplified to it, but you should note that they are really the same. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.